Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are discussing about anything and everything about the construction. Today also, we are going to discuss about a very important topics that every civil engineer who are starting their journey as a site engineer or the training engineer at a site, that how to calculate the cement, sand, and aggregate quantity in a concrete mix. Nowadays everything is coming from the batching plant, but if we want to do concrete at a site level, we need to give the precise quantity of each and every material. In order to get that, you need to calculate the quantity. So how to calculate, that is our topics today, and stay tuned until the end to get the full information about how to calculate the cement, sand, and aggregate quantities in a concrete. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's start with first things. To calculate the quantity of cements and aggregate, we need to know the what is the mix ratio. What is the mix ratio? Mix ratio is that what percentage of cement, what percentage of aggregate, what percent of sand is there in the concrete mix. In here we are taking an example of M15, that is 1:2:4. What is M15? That is the 28 strength of the concrete is 15 MPa. So what is the mix ratio? That is 1 part of cement, 2 part of sand, or 4 part of coarse aggregate. And this is the nominal mix. And another type of mix design is the design mix. So what is the nominal mix and what is the design mix? I have made a detailed video. Please click the link or in the description box. You will get the full information about nominal mix and the design mix. So now we get the mix ratio, that is 1:2:4. Now we need to know what is the volume. Now here is a catch. Now if you want to do the concrete for 1 cubic meter, that is called wet volume. Now what is the concrete? Or that is sand, cement, aggregates, and after adding the water, it become the wet concrete. And now whatever the quantity we are measuring in a dry condition, and if we calculate for 1 cubic meter and same thing is not in a dry condition, what will happen? We will not get the exact 1 cubic meter of concrete. So that is why we need to convert the wet concrete into the dry volume. So what will be the dry volume formula? That is a wet volume plus no, sorry, it is a wet. That should be wet. Wet volume plus 54% of wet volume. That means here is also, that should be wet. Okay, that means one cubic meter is wet volume and 54% to be added. So 1 plus 0.454 become 1.54. So this will be become the my dry volume. So why we need to calculate dry volume? Because every material or every ingredient we are calculating on a dry condition. So that is why we need to know the dry volume. So 1 cubic meter of wet concrete, we need to calculate for 1.54 cubic meter of the dry concrete. Now, what is the next part is the what is the sum ratio of the ratio. What is the sum of the ratio? Is 1:2:4. That is 1 plus 2 plus 4. That becomes 7. Now, we know the mix ratio, that is 1:2:4. We need the volume, that is 1.54 cubic meter, in order to get the 1 cubic meter of wet volume. And the sum of the ratio 7. Now, what will be the cement calculation? So, how much percentage of the cement? That is only 1 part. So, 1.54 into 1 divided by 7. 7 why? Because the sum of the ratio. And if it calculate, it is coming 0.22 cubic meter. So, it is the volume of cement quantity will be in 1 cubic meter M15, so 0.22 cubic meter. Now, if we want to calculate this in the CFT, so 0.22 into 35.315, it's become 7.77 CFT. So it's become cubic meter, it's become CFT. Now, in order to get the kg, so how we can convert it into the kg? The density of the cement or the specific gravity is 1440 kg per cubic meter. So in kg, 0.22 into 1440 is equal to 3.16.1 kg. So 1 cubic meter concrete of M15, we need 316.18 kg. Now, if you want to convert into the bag, what we know that 1 bag of cement is equal to 50 kg of cement. So in bag, 316.8 divided by 50 is equal to 6.4 bag. So if you want to make it a cubic meter, CFT is a kg or cement, whatever you want to make the ratio, you can calculate from the same thing. So here it is for M15, for cement quantity is 0.22 cubic meter, 7.77 CFT, 316.8 kg and 6.4 bags. Now we have calculated the cement. The next part we need to calculate the fine aggregate. Now the same formula is the same because we have already calculated the cement. So what will be the mix, total mix sum of the ratio 7, and what is the percentage of fine aggregate or the sand in the mix? That is become 2. So what will be the formula? In cubic meter, 1.54. What is in cubic meter? Why? Because 1.5 more is the cubic meter. It's not in the CFT or it's not in the kg, because it's the wet condition. It is the volume mix. So that is why it is coming in cubic meter. So 1.54 into 2 divided by 7. 2 is the percentage and 7 is the ratio, sum of the ratio. So here it is coming 0.44 cubic meter. So it becomes the 0.44 cubic meter of fine aggregate is required for M15 grade of cement concrete. Now we need to convert into the kgs. So what will be the kgs? 0.44 into 1450. It is also the fine aggregate specific gravity for 1450 kg per cubic meter. So what will be coming? 0.44 into 1.450 is equal to 638 kgs. Now we need to calculate in the CFT. In CFT, it's 0.44 into 35.315. It is the conversion factor. All you know that from cubic meter to CFT, we need to multiply with 35.315. So it's become 15.53 CFT. So why we are calculating in cubic meter, kg and CFT? Because it's in the side, we are making the measuring box like this in the CFT, because it is all in the volume mix. So what we are doing, what is our normal practice? We are making 1 bag of cement. What is the area 1 bag of cement, or what is the volume of 1 bag of cement? On that basis we make a measuring box. So 1 bag of cement and 2 is sand and 4 is aggregate. So that is why the CFT is very important in order to get the right kind of material. So after getting the fine aggregate, what is my part? Yes, that is a coarse aggregate we need to calculate. So in the same, in cubic meter, how much will be coming? Total volume is 1.54 and 4 part of aggregate is there. And what is the sum of the ratio? Sum of the ratio is 7. Sorry, where it is going? Sum of the ratio is 7. So 1.54 into 4 divided by 7. Why? 1.54 is my volume, 7 is the sum of the ratio, and 4 is the 4 part of the coarse aggregate inside the volume. So 1.54 into 4 by 7 is a 0.88 cubic meter. In CFT, again, what is the conversion factor? That is 35.315. It is coming 31.072 CFT. And in kg, again, it is 1500 kg per cubic meter is the specific gravity. So we need to calculate the kg itself. So 0.88 into 1500 is 1320 kg. So what will be my percentage? If I want to make it in the cubic meter, for 1 cubic meter of concrete of M15, cement will be 0.22 cubic meter, fine aggregate will be 0.44, and coarse aggregate will be 0.88 cubic meter. And if you want to make in a kgs, 316.8 kg cement, 638 kg fine aggregate, and 1320 kg of coarse aggregate. So these are the calculation formula. It's so simple. Let's summarize. First, we need to know what is the mix ratio, that is 1.2:4. Then we need to convert it from the wet volume to the mixed volume. If it is a 1 cubic meter, then the dry volume will be 1.54 cubic meter, and every calculation to be made on the basis of dry volume. The sum of the ratio 1:2:4 is equal to 7, and the cement is 1.54 is divided by 1 part of cement divided by total sum of the ratio, that is 7. In the same way, fine aggregate 1.54 into 2 part, that is the 2 part of fine aggregate divided by sum of the ratio. And in the same way, coarse aggregate 1.54 into 4 part divided by sum of the ratio, that is 0.288 m cube. And these are the formula for the calculation of the cement, sand and aggregate in nominal mix. Or if you want to do at the site, apply this and you will get the exact amount of cement. So here it is a catch that whenever you are making, maybe there's some wastage, so you calculate as per your requirement or your as per wastage calculation also, so that you can get the right kind of material and right kind of the quantity. So next is M20. What is the M20 grade? That is 1:1.5:3. So how we can calculate that one? This is your homework. Please do the calculation and let me know in a comment section, so I will also know that my topics is valuable for you and you get the inspiration and you can calculate the whatever the grade of concrete as per this formula. And I hope you find this useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you'll get immediate notification. And I am waiting for your valuable feedback, so that from your valuable feedback, everybody will be benefited. And if you want to know anything about construction and quality control, please let me know. I will come with more content like this. And thank you once again for watching me.